Where did humanity truly come from? In the faith of Christianity, we emerged from that lost Garden of Eden. In the legends of ancient China, we were molded from clay by Nua. In the myths of the Norse, our world was born from the primordial giant Mir. In the philosophy of ancient India, we exist within the cyclical dreams of Brahma. In the beliefs of ancient Egypt, we are the tears of the sun god Ra. In the Aztec legends, God shaped us with precious maize, mingled with the sacrificial blood of the gods. These magnificent myths carry each civilization's most romantic imagining of their own origins, yet is there a story that can transcend the bounds of culture and geography, and with firm evidence, tell us a universal truth about all humanity? Yes, this story is etched into our bodies, engraved in the depths of every cell. It is the epic of science, the quest for the origin of life. Where do we truly come from? This is the ultimate question that has haunted us for thousands of years. Yet in just the last 2 centuries, we have turned to science, attempting to write our own genesis, the story of human origins. The story begins with Darwin's theory of evolution. He taught us that all life shares a common origin, that we are shaped by the power of natural selection, by the great tree of life. Yet how do we inherit traits from our parents? What is the micro-mechanism of evolution? On these questions, Darwin left us with a mystery. The answer lay hidden in the pea garden of a monk. For the first time, Mendel's genetic law revealed the statistical principles governing the intergenerational transmission of traits. Yet what were these genetic factors, and in what form did they exist? This remained unknown, a deeper scientific mystery. At this turning point, a physicist sparked a revolution in biology with a slender volume. In What is Life? Schrödinger boldly proposed that the genetic material would be an aperiodic crystal, with its information encoded in the arrangement of atoms. The book became a beacon, illuminating the path forward and drawing brilliant minds such as Watson and Crick into the pursuit of biology. In 1953, the great double helix structure was unveiled. Watson and Crick showed that the blueprint of life was written in a script of 4 bases, A, T, C, and G. At last, the bearer of the Book of Life had been found, yet new challenges emerged in its wake. How could it be read? And how could the vast code of 3 billion characters be deciphered? The earliest sequencing methods were clumsy and inefficient, like copying an encyclopedia by hand. Even reading a few bases was a struggle, let alone the entire human genome. The dream of deciphering the Book of Life seemed out of reach. What was needed was a technological revolution, a key to open this formidable lock. At this pivotal moment, the name of a Chinese scientist shone brightly, Ray Wu. In 1971, he published a landmark paper introducing a novel method, primer extension. In this approach, he designed a known primer, like a precise key, to fit into a chosen spot on DNA. From there, DNA polymerase acted like a photocopier, starting at that point and copying one base at a time to reproduce the previously unknown sequence. This method did more than simply improve efficiency. It fundamentally transformed the logic of sequencing. It made sequencing more accurate, more controllable, and easier to automate. Ray Wu's groundbreaking work planted the vital seed for all modern sequencing technologies that followed. Nobel laureate Frederick Sanger, building on Ray Wu's ideas, refined the approach and developed what became the gold standard of DNA sequencing, the Sanger method. Sanger himself openly acknowledged that his work was profoundly influenced by Ray Wu. It is fair to say that Ray Wu was a true pioneer and a founding figure of DNA sequencing technology. With this key in hand, humanity finally had the confidence to launch one of the most ambitious scientific enterprises in history, the Human Genome Project. In a global collaboration, scientists from multiple countries worked for 13 years at a cost of $3.8 billion, culminating in 2003 with the complete sequencing of the first human genome. For the first time, we could fully read the genetic instructions that make us who we are, and behind it all were the technical foundations laid by Ray Wu. But the story did not end there. Sequencing technologies have advanced at an astonishing pace, with costs plummeting at an astonishing rate. The Human Genome Project has quietly evolved into the era of genomes for everyone. Today, individual genome testing is becoming as simple as a routine medical examination. What does this mean? It means we can predict disease risks and move toward truly personalized precision medicine. We can trace the migrations of our ancestors, uncovering the deep, ancestral ties that bind us to the land and to each other. Therefore, We are not only answering the question of where we come from, but also unlocking the genetic health code that will guide where we are going. Looking back on this grand and tumultuous journey, from Darwin's theory, to Mendel's laws, to Schrödinger's prediction, and finally to the structural breakthrough by Watson and Crick, thanks to Ray Wu, the humble Chinese scientist, whose brilliant vision forged the key that unlocked the Book of Life. And yet, the Nobel Prize was ultimately not awarded to Ray Wu. In the history of science, a silence remains. Scientific truths are ultimately remembered. While sometimes history forgets the names, he may never be as widely recognized as those before him, yet he was the key bridge that turned great theories into technologies. Thanks to him, the answer to life stepped out of the realm of philosophy and abstraction, and became something we could finally read. To Ray Wu, and to all the unsung pioneers who laid the foundations for our quest to uncover the mysteries of life. Their wisdom continues to illuminate our journey toward self-discovery. Exploration never ends.